Hi, in this video we're going to solve a problem involving a circle inscribed inside a triangle. Now we've got this diagram here. The circle, it says, is radius 12 and it's inscribed inside this isosceles triangle ABC where the angle B is 52 degrees. Determine the area of the triangle. Now in order to work out the area of the triangle we need to do half times the base times the height. So let me just write that formula. It's just half multiplied by the base b multiplied by the height h. So we need to find out what this base is here, and we need to work out what this whole height is here. Now we can work out this bit of height here because that's just the radius of the circle, right? So we can put in this 12 here. That's 12 centimeters. But we also need to work out what this height is here as well and add it onto the 12 to get the overall height. Now, there's something called a circle theorem, which is an angle property to do with circles, and we explore that later in the skill on circle theorems. But for now, it's that if we have a line which touches the circle like this, known as a tangent, and you have the radius of a circle like this, and it meets that tangent, then that angle between the two is 90 degrees. You can probably see it looks like 90 degrees, and indeed it is 90 degrees. So we've got that. And also note that because the isosceles triangle has this as its line of symmetry, that 52 degrees is exactly cut into half here. So we know that this angle here is going to be half of 52, which is 26 degrees. Now it's starting to look a bit messy, so let's just draw out this triangle separately. So we've got this triangle here like that. And that was our right angle. We've got the 26 degrees here, and we've got the 12 at the bottom. And we're trying to find BO, which is this height here. So let's just call it X. Now, remember how we use trigonometry to relate the two side lengths of a right angled triangle and the angle of interest. The angle of interest is just the angle that's given that's not the right angle. And these are the two side lengths of interest. Remember, we label the triangle first relative to that angle of interest. So the X is the hypotenuse of the triangle, the longest length. We put an H in a circle. And this 12 is opposite the angle of interest, so we call it the opposite O. And then remember this mnemonic we use. So SOHCAHTOA, SOHCAHTOA, like that. And then we use our side lengths of O and H to select the right one of these. So O and H is here, so we're going to use that one there, right? And that is short for sine of the angle of interest. Let's call it theta. So let's call this theta here. Theta is just a Greek letter. Is equal to the opposite. So the opposite here over the hypotenuse there, right? So now we just need to substitute into that. So sine of the angle of interest, which is 26 degrees, equals the opposite, 12, over the hypotenuse, which is X. Now, because this variable is in the denominator, there's a nice quick way to deal with this to make it escape the denominator. You can swap the thing you're dividing by and the result of the calculation. I'll explain why this works in another video. But we've swapped the X and the sine of 26 to give you X equals 12 over sine of 26. And then if we just evaluate that, 12 divided by sine of 26, that is equal to 27.374. So we've now got that length there. Here, if I just put it in, it's 27.374, like this. And now we've got the total height. And now we've got the total height of the triangle because it's just a 27.374 plus that 12. So that's great. So now all we've got left is to work out what this base of the triangle is. Now, there's various ways we could do it, but we could just focus on this triangle like this. So if I just highlight it, we could focus on this right angled triangle here. So let's just draw that separately. Got this triangle here. We've got the angle 26 here, degrees. And we've got this total height is a 27.374 plus the 12. So if I just add the 12 to that previous result I got, we've got this total height is 39.374. And we're trying to work out this base at the bottom. So let's call it Y. I'm going to use trigonometry again. Angle of interest is here, sides of interest of here, and then this is opposite, so that's O, and this is adjacent to, next to that side, so we label as A. And if we look at our SOHCAHTOA, we can see the O and the A is here, so we're going to use tan this time. So it's tan of the angle of interest is equal to O over A. So we've got tan of theta, which is 26 degrees, is equal to O, which is Y, over the A, which is the 39.374. Now we just need to multiply both sides by that 39. So it's going to be 39.374 tan 26 is equal to Y. So let's do that. And we get Y is equal to 19.204. Okay, so we've got that this bottom length here is 19.204. And if we just multiply that by 2 to get the whole base, that's going to be 38.408. Right, so we've got everything we need now. Now we're going to do the area of the whole triangle. The whole thing is half times by the base, which we said was a 38.408. So 38.408 multiplied by the total height, which we said was this 27.374 plus the 12, which was this 39 here. So it's 39.374. Let's just put that in our calculator. And that gives you 736.1. Is it in centimetres? Yes, it is. So centimetres squared will be the area. So there we go, 756.1. And that is the final answer.